Welcome geometry students to the really short video before the main event. In this video I'm just going to introduce two new congruence, one's a postulate, one's a theorem, so I'm not sure what to call them. Congruence statements, I guess. Things that you can use to prove that triangles are congruent. So before I talk about these two, I just want to go back to what we've already talked about. We've talked about side, side, side congruence, and we've talked about side, angle, side. That's when we have two sides and an included angle. We can use that to show that two triangles are congruent. And if those two things are true, then that means that all corresponding parts of congruent triangles are congruent. So if we can prove that three sides of two triangles are congruent, or a side, an angle, and a side, and that angle is the included angle, we can say that any of the parts of one triangle are congruent to the corresponding parts of the other triangle. And in this lesson, I'm going to introduce the other two proofs that can be used. These are not proofs, they're one postulate, one theorem, to prove that triangles are congruent. So we have angle, side, angle congruence. That means that we have an angle, another angle, and then the included side between those two angles. But wait, we also have angle, angle, side. One's a postulate because we just have to assume it, and then angle, angle, side congruence can be proven from the other congruence postulates, so we call that one a theorem. That's why it's just got a different term, but it's the same sort of thing. We can use either of these in proofs. So angle, angle, side is interesting because it's just two angles and then a side. The only thing you have to watch out for there is that the angles and then that third side has to correspond to the same side connected to the same angle on the congruent triangle. So if you read through what it says, if two angles and a non-included side of one triangle are congruent to two corresponding angles and the corresponding non-included side of the other, then the triangles are congruent by angle, angle, side. Now, just as important as what's on here is what's not on here. Notice that angle, angle, angle is not a congruence postulate. So if three angles of a triangle are congruent, actually, we could have three angles of two triangles that are the same, but the side lengths just scale up or down as much as we want them to. And if the side lengths can be different, then we would say that those triangles aren't congruent. So angle, angle, angle doesn't work. Neither does side, side angle. Side, side angle is a little more interesting because if we have two triangles that have two sides congruent and then a non-included angle, there are at least two different versions of that side angle that make two different kinds of triangles for the same side angle. So we can't prove it because there's at least one counterexample that is not congruent. But these two work, okay? So we're going to do some practice problems working with these two congruence statements in the next video.